Hey everyone, this is Madhav. We're back with the 0 to ML series, and finally, we're actually at machine learning libraries. This time, we're going to learn about Pandas, which is the de facto data processing library within Python. We're again going to be using Kaggle, which you have set up in the past workshops. So you can go to the link in the description, get this URL. When you open it up, click on copy and edit, and you'll be good to go. So this time we're learning about pandas. What does pandas do? Well, it can allow us to do some data analysis. And in this workshop, we're going to build towards building unique data visualizations that will help us with future machine learning, as well as just, basics like answering sales, business analysis type questions. So let's get started. When I first click on copy and edit, I will get a screen that shows up like this. I'm gonna click on these code cells one at a time, click on the play button. It's going to, do the spinny thing while it's waiting. And after this goes green, the session has been started up. Then the code will execute and I'll see some stuff come up down below. Anyways, while it's doing that, let me just give you an intro to Pandas. So what Pandas does is, it is allowing us to, one, load a bunch of different types of data, and then two, run common types of analyses on that data. Things like finding correlations or averages or sums or other numerical operations. Filtering the data, sorting the data, things like that. So we're going to learn about all that. Anyways, the loading has finished here, so I am good to proceed. The first thing that we're going to look at in Pandas is how we load a data frame. Now, I could just say, hey, there's this pd.readCSV function, but that probably is a bunch of random words that you've never heard of. So let me explain what that means. We store data in different file formats. For example, one file format that's used on websites is this JSON file format. Another file format that's common in machine learning is the CSV file format. What a CSV file format is it has, well, as the name implies, comma-separated values. So as you can see here, the top of the CSV file has this header row. It has a few columns, so the X, Y1, Y2, and Y3 column, and they're separated by commas. After that, you have one column for each of the rows. So each row of data, it has a value, and it's separated by a comma. These values don't just have to be numbers, they can also be text. So a CSV is very versatile. By the way, any Excel spreadsheet or tools like that you've used, those are all under the hood, they're also CSVs. So each of these columns is separated by a comma, and each of the rows they separate values by commas. So hopefully some of you have seen this file format before. Anyways, I found this sales data CSV file that we can use. You can see it has a bunch of details, different columns like different order numbers or prices of different orders, dates, quantities, things like that. So this is the data that we're going to be playing around with today. Now, hopefully, you can better see. So I imported pandas as PD, so this is just a shorthand. So I imported this library. It has a built-in function that I can use. So I can call pd.readCSV, and I can pass it the name of the file. So I looked here, I saw the CSV file was here, and I copied the file path. That's how I got this. Once I run this, I can, inquire about the stuff that I read. So for example, I could look at the shape of the data set, which shows me the rows and the columns, or I could look at, which columns are in this CSV file. So you can see I have, a little under 3,000 rows. I have 25 different columns, and here are some of the columns I have. Now, if you're looking at this for the first time, this might seem like black magic. How do I know that there's a df.shape thing or a pd.readCSV? Again, keep in mind, this is not some black magic that's going on. So pandas pd.readCSV, that's a built-in function. I can search up, pandas.readCSV, and it will show me some documentation. It will say, okay, this is the function. Yes, it's messy, but there are a bunch of things, that you can pass in. And if you scroll down for a long time, eventually it will show you a example, perhaps not a very good one, but an example of how you can use the function. Now, keep in mind this function, it is returning, it doesn't say here, but if you scroll down far enough, or Control F the returns, it returns a data frame. What is a data frame? Well, again, you can search up the docs. So, we could search here, or I have it open here. A data frame is just a class. So we learned about this stuff in the last Python workshop. Now, yes, this is a complicated class. It has a lot of things built into it, but that's good for us. Someone's wrote all of the code about the attributes we can access or the methods we can call. So now we have less work to do. And you can even, show source. You can search up the source code of the class, check that it is real Python code and not black magic. So that's the convenient thing about pandas. Now, if you're feeling lazy, this was the back in my day type approach to figuring out how pandas works. Today, we can simply use ChatGPT. So if you're, wondering, okay, how do I use pd.readcsv? You ask ChatGPT. Let's say you didn't know that the encoding parameter was needed, like I didn't. You'll try and run it, you'll get an error, and you can copy paste this error into ChatGPT and it will suggest to you, hey, try this thing. So with that, hopefully you're feeling a little bit less scared. It's not black magic, it's just, you know, normal Python functions, normal Python classes with instances and attributes and things like that. Anyways, spiel aside, we have loaded something called a data frame. Let's see what we can do with it. One thing we can do with it is we can call a head function on it. So this method, it will show us the first few rows of data. And you can see, I have various orders and various information about these orders listed here. I can also call a .info method. This one, it tells us a, neat little summary of which columns are available, how many of them are non-empty, and the data types associated with them. So, some are integers, others are floats or decimals. And finally, most of these object columns, they are just text or strings. Finally, I can call the .describe method. So this is simply for the numerical columns here. And for the numerical columns, it will give us, statistical information like the number of entries, the average entry, the standard deviation of entries, and so on. So those are some basic pieces of info about pandas. You're often going to be using the readcsv function, which will return a data frame, and your data frame is the thing that you'll be interacting with all the time. It's the main class that we use in Kaggle. Okay, with that said, now we know how to load our data. How can we now do some basic data analysis? The first thing that we might want to do is, we have a bunch of rows here. We might want to access a single row out of those. Just like you can, access let's say a list, we can provide some index. Here we can provide a column name and it will allow us to choose one of all of these columns. So let's try it out here. When we, just index into the sales column, then we get something. This thing in question is this. It's another class. So if I search this up on pandas, pandas doesn't have very good search, but here we are. So it's just another class. And it has its own built-in methods that we can learn about. One method that's built in is the .sum method. It will take all of the numbers in that sales column and it will add them together. This can give us the total, sales. So we're ordering them together, like we're adding them together, and the net results we can print out, store to a variable, things like that. So that's how we can use pandas to answer some kind of business question. Let's look at some more complicated business questions. So let's say we wanted to know which country has the most orders. So here we want to separate the data into different countries, and then we want to figure out, okay, within each group of countries, what has the most orders. Luckily, Pandas has a built-in method for us. It's called group by. What it does is, well, earlier I showed you when I have a data frame and I call, let's say, head on it, well, all of the rows are simply listed, one after the other. Well, group by, what it does is it splits up those rows. It can break them up into different buckets or groups. And since we specified the column country, it will break them up based on country. So just so you have a visualization, before we had all of those rows one after the other. Now we have buckets or groups of rows. So let's say 10 rows are from Japan. So all the rows that have a country, which is Japan, get put together. In contrast, the rows that have France, those get put together, and so on and so on. Once I do this, I still only have, a data frame with each and every column. It doesn't tell me anything about all of the orders. So to get the orders, I have to index into that column. Now to show you this, I'm going to show you step by step. So let's say I do just the first part, df.group by country. I don't get anything helpful. Let's see if we have a head method. So you can see I have all of the columns here, all of the information. I don't want all of the information because I want to know about just the orders. So if I add this part on, the quantity ordered, let's try adding this on here. Now you can see I have just a single column with the quantity ordered. So this is what I want to be working with. After I have that, I have split up the rows by country and then selected only the quantity ordered column. I can call the .sum method. Why? Because I want to know which country has the most orders. So I want to figure out what are the total orders grouped by each country. Because we created the group by object, the reason why I say it in that weird way is, if you saw earlier, when we called group by, we changed the class, this is a new class. It's not the regular data frame class. Anyways, that's why I say we create a new object. With this object now .sum, it doesn't add up all the rows. It will be adding up the rows for Japan, and then adding up the rows for France, and then adding up the rows for, one country at a time. So if I show you, now you can see I have the rows in each country. This is a concept that people can find confusing. So again, take a moment to pause if you need. Okay, assuming you've done that and you are familiar with the concept of splitting up all of the rows of the table into buckets or groups, and then indexing particular columns, and finally, adding values, taking the average, taking the min or the max or whatnot. Here's a little challenge that you can do to check if you understand. Try answering this question. Which product category has the highest total MSRP? As a hint, you'll just need to use group by, and you should probably check the column names with df.info. So you'll need some of the column names here in order to know what do I need to add together. Take a second, pause, and we'll do it afterwards. All right, assuming you've given it a try, let's try going through this. So first it says which product category, and then it says has the highest total MSRP. So one piece of information I get is I need to check different product categories. So I'm going to group different product categories together. Now there's no product category column. If you went to df.info, you would see that we instead have a product line column. So that's the name I'll use. So we're going to group by product line. Next it says, if I did this, you can see I have all of the columns. It says something about the MSRP though. So I'm instead going to index into just one column, which is the MSRP column. Again, I checked df.info up above to realize that this column existed. So now if I do this, you'll see this looks much better. It is, just one single column with the MSRP values. Finally, I want to be able to split up across product categories. So I want to know what is the highest total MSRP. Total to me tells me I need to add things together. So that's what I'm going to do. And now I can see across product categories, the highest MSRP is with the classic cars. So that's that question answered. Hopefully that shows you how you need to, think and break down the question into parts, like, what are you grouping by, which columns do you need to access, which operations you need to perform. For instance, if I said average MSRP instead, I would call the average function. And if that doesn't exist, it's because it's actually called the mean function. Anyways, so now I can go and compare, and I see that classic cars has the, highest average as well. Let's try the highest, well, I think that's a good place to wrap up with the highest whatever. Maybe we could instead try as the minimum MSRP. This question can be interpreted as, I want to find just the minimum value within each of these product categories. So if I do this, I'll see the minimum value here is 35, minimum value here is 33, and so on and so on. I hope that gives you some clarity. Trying to go through that exercise. We'll have more to come soon. Here, you can see that I'm continuing with similar questions. So this time, we're doing the mean and we're also sorting values. So sorted the values in descending order so that we get the highest average first and then so on and so on. Here's an interesting one. So sometimes we want to locate very, very specific pieces of information from within our data set. So we don't want to get aggregate results, as in we don't want to get results across all of the rows. We want to just find a specific row. Here, the .loc function is useful. So one thing to keep in mind, let's say we're answering the question, what's the highest price product code? So which product code has the highest price? We might try using our max method that we just saw, but if we did, let me show you what we get. Print, let's say df at price each. I found the price each column again by looking at df info. So let's say I just did this dot max. You'll see that I get back the actual value. So what is that price? It doesn't tell me anything about which row it's in. And I need to know the row because I don't actually want to know the price. I want to know the product code in that row. So .max is not useful. Instead, what we want is index max, which gets us the row number with the highest price. In case you hadn't, seen it, when you do .head, you have these row numbers. So these are called indices. So that's why we have a max index function or a, index max function so that we can get those row numbers instead. Once we have the row number of the highest, the row with the highest price, and we can see that because we were only looking and checking the max operation on the price each column, then we can use it with the loc function. So the loc function is taking in a row number here, and then it's taking the column name we want to see. So we want that highest price row, we pass in that row number, and we want to look at the product code associated with that row. Once we run this, we can see that the product code is this. Keep in mind that with the loc function, we can pass in a list of column names that we want to look at. That might be helpful. So this is a very, very flexible function. I would definitely ask ChatGPT about it. Hopefully that makes sense, the loc function. Next, let's take a look at, well, sometimes we're not grouping by, we're just doing some simple stuff. Let's take a look at another type of data. So here we're looking at years instead of just, dollar amounts. So if we want to find how many years of sales data we have, well, we want to look at the latest year. So the highest, year, maybe it's 2005 or something. Also, we want to look at the earliest year. Let's say that's 2001. And then the number of years, if we have that, is given by this formula. For example, if we have the latest year as 2005, the earliest year is 2003, then that means there is 2003, 2004, 2005. There's 3 years, and we can get that with this formula. Anyways, if I run this, it seems my memory was spot on. This data does indeed have 3 years of data. Keep in mind that, these functions that we've been showing off, they're all for numerical data. There are other functions that, are built in for, let's say, text data or true or false data, etc., etc. Okay, here's a complicated one. Take a deep breath if you need. Whenever we were doing the .log thing, so far we were just using a single index or a single row number. What if we want to filter the table more heavily? Let's say we want to answer this question. How many US cities we deliver to? Well, in this case, what we want to do is, in this case, we want to take our df country, so, the column of all the country names, and we want to check, which countries, which rows are equal to the USA. Now, when we do this, this creates what we call a Boolean mask, which is simply a list of true or false values. To show you, here's what a Boolean mask looks like. It's just a list of true and false values. You can see I have true, false, false, true, true, and that corresponds to my data set. So if I do df.head here, you'll see, this is, NYC. So this, oh, you can see the country here. So the first one is true. It is the US, as we saw here. But the second one is in France, so that one is not the US. And that's why we got false. So again, this is a Boolean mask. It goes through, checks each row for the condition that we specified, and then returns a true or false. What we can do with that is we can use it like we were using those column names. We can use it to index into the data frame. So this will now filter and only pick the rows where we got it true. So after we filter, let me show you perhaps up here. So if we filter by, Boolean mask, you can see that I have 1004 rows, but if we don't filter whatsoever, you can see that I have, nearly 3000 rows. So when we're filtering by the Boolean mask, we're getting rid of the rows where the values turned out to be false, based on the condition we specified. Finally, even after we filtered, if I look at the columns that I have, I have all of the columns, I have the entire data frame. What I want to have is just the cities, because that's the question we were asked about. So what I do is I take the filtered datasets with the right rows, I select the city columns within them, and then I call the .unique method, which tells me how many unique cities are in this, thing that I've selected. When I say thing, technically I mean this Pandas series. That's the class we talked about. Anyways, so after I have a list of my cities, here are a few examples of the cities, I count the length, and that will allow me to answer my question. how many US cities we deliver to? It's 23. This is a confusing concept for many people, so it's okay if you find this a little bit much. Take a second, review each step of how we're creating the Boolean mask, filtering away the rows that we don't want, then filtering away the columns we don't want, and finally using the method that we need to answer a question. Okay, hopefully you have paused the video and taken a look. Makes sense, hopefully. Now, I will give you a few hints because I'm going to test you on this concept. So, oops, I should get rid of this. Let's fill in the blank instead. Which French city has the highest total sales? Pretend you didn't see the solution right there. Use some of these hints to figure out how you will try and answer your question. Hopefully you've paused and had a go. Let's take a look at this together now. So, which French city has the highest total sales? So one hint I already gave you, we want to look at French cities. So, we're going to need a Boolean mask that's related to the country being France. So I'm going to use that. And this is also giving another hint. If I want to select multiple columns up here, I just use this syntax, but I can also use the loc function that we saw earlier. Here we are selecting the rows that we want, and here we're selecting the columns that we want. So if I do this, you can take a look at what we get. We get a bunch of sales figures for cities that are French. So we want to figure out which French city has the highest total sales. How do we do that with this filtered data frame? So here's what I'm going to do. First of all, I see which French city, so I'm going to need to compare cities. So I'm going to do filtered.group by, and then I'll group by the city. And then I see highest total sales. So clearly I need the sales column, and total tells me I need to add together all the sales. So now I can see which French city has the highest total sales. Comparing these values, I can see it's Paris. So this is a somewhat involved question. You have to think through what do you need to do with the original data in order to be able to answer this question. And the steps are you need to create a Boolean mask, you need to filter away the rows that you don't want and the columns that you don't want. And finally, you need to run some computation on the filtered data in order to get the result you want. So Kaggle, Pandas, it does take a bit of thinking. You have to think through the question you're being asked so that you know which methods you can call. It's not just about memorizing the methods. And if you ever do like a technical data science interview question, you'll need to pay attention to details. It's very easy to mess things up here. I'll show you an example of messing things up. One time, I was just like, okay, which French city has the highest sales? So I was like, okay, select city. Well, actually, um, I want a Boolean mask still to filter out the non-French rows, but then after that, just select sales and then do max. But this isn't right because we're talking about total sales, not just the highest sales. So it doesn't make sense to just call the max operation. It will find you the highest sale amount, but not the highest total sales. So there are lots of like tiny details that you need to pay attention to, especially if you're interviewing and you're using Kaggle to answer some questions. Hopefully that makes sense. Now we're going to continue to look at some more advanced uses of this Boolean filters. So if you're confused, do pause. It's going to get more complicated here. So the natural extension now is, well, what if we want to operate and filter not based on text data, but numerical data? First, we could just use other Python operators. For instance, we could check sales amounts that are higher than 1,000. So this is for high-value orders. Again, this is going to produce a Boolean mask of true and false elements, and we can filter by them either by using this syntax or by using the .loc syntax. So here we can see that we have around 2000 high-value orders. Let's see if we can get, even higher value, so higher than 10,000. Now we only have, 16 high-value orders that are higher than 10,000. One other thing that we can do is instead of just, having one of these conditions, we can combine conditions. So for instance, let's say we have two things that we want to filter for. One is we want to look at only motorcycle orders, and two is we only want to look at orders from Spain. What we can do is we can create a Boolean mask that combines these two conditions by using this AND operator. Keep in mind you need to have these parentheses or else, you're going to get some kind of error. But if I do have these parentheses, again, this is just a Boolean mask. It's just going to be a list of true and false values, mostly false values, because, this is a very, very niche thing, right? Selling motorcycles to Spain, you don't expect many rows to be associated with that. Here we are again applying our Boolean mask, and you can see there are 19 orders that involved selling motorcycles to Spain. Here's a little exercise for you, a little bit more complicated of an exercise, so pause here. You want to find the number of trains sold in Asia, and, well, you don't know which countries are in Asia unless you look at the prior results. So some of the prior information about different cities or countries that exist, that will tell you which countries are in Asia, and then you will be able to find trains sold there. So take a second, pause there, and then I'll take it up with you. Okay, assuming you've paused. So the first thing is, I don't know which countries are in Asia in this data set. We got to find that out. So I'm going to do df. I'm going to select the country column. Again, I knew this column name exists because of the df.info function. So this is where I go to check which column names I need. I'm just walking through the step-by-step process, I guess, instead of just giving you the final answer. So you get the countries, and it's going to give you a big list, not so useful. But if I call unique on it, now it gives me, all the possible countries in this data set. If I look at which ones are in Asia, well, I have Singapore, I have Japan, and I have the Philippines. So those are my Asian countries. I'm going to define those here. Actually, I'll commit them to memory for now. So find the number of trains sold in Asia. Okay, so now I want to find first sales records related to Asia. So I'm going to create a Boolean mask using the technique we just learned about. So first of all, I need those parentheses as we talked about. And then I'm going to, check, is the country equal to Singapore, or is the country equal to Japan, or is the country equal to Philippines? Now keep in mind the capitalization here matters. If I did, Singapore, lowercase, then I would not get the correct results, so be careful with that. Now that I have constructed my Boolean mask, I can do df df at bool mask to find just row records that are related to countries in Asia. The only problem is that this doesn't completely solve my problem because, this is for all sorts of things, all sorts of, sales, but I only want to look at sales of trains. Luckily, keep this in mind. If I check the product line, I will be able to figure out that there is a trains product line, so I can filter for that. So what I'm going to do here is I'm going to be neat. I'm going to say this is the Asian countries, and now I'm going to create a separate Boolean mask, which is for df at product line equals train. I don't recall if there's an S or not, so I need to be careful about that. There is an S. If I don't have the S, it's not going to work. So now I'm going to put in the S, make sure that's there. And now I'm going to have Asian train sales is going to filter this by my second Boolean mask. I think this is a warning, but I don't think this is an error, so I'm going to proceed for now. Find the number of trains sold. Okay, so I need to add together all of these train sales. So the last thing I'm going to do is print, we sold, and then we have Asian train sales, sum up. I can't just sum up all of the columns, I just need the sales, or I just need the product quantity. So let's figure out what we can use to find the quantity. Again, looking at the columns. Quantity ordered, I need this column, so I'm going to copy that. Come back down here. So we access that product quantity column and then finally call dot sum. So we sold 223 trains to countries in Asia. You can see that process is a little bit involved. You got to think through multiple steps, refine all of your filters, but in the end, if you combine the right operators, you can get the answers you want. That will wrap up our section on data filtering and computing these basic statistics. The last thing I'll mention is that we can have some fun and, make things more visual. So for instance, here we were computing, single stats, like, what's the total or what's the mean. We can also compute interrelated statistics, like the correlations. I got this code from ChatGPT, which is where you should get all data visualization code after 2022. Anyways, what a correlation heat map does, that's this code right here. It tells me if colors are warmer, then two numerical columns are more interrelated. So clearly, a column is related to itself, so order number is related to order numbers. That's not very helpful. But we can also see, let's say price each is related to the MSRP, or sales is related to the MSRP, and so on and so on. So this kind of information is pretty good. It's pretty helpful. Oftentimes, what you're doing is you're working on machine learning models where you want to take some information, some partial information, and then, predict something that you don't have. So let's assume like we had, these 5 pieces of data, but we didn't have the MSRP value. We might take a look at this correlation map and figure out that, okay, if there's a high correlation with certain values, then we want to take those pieces of data that have a higher correlation with MSRP and use those to make our predictions. I hope that makes sense to you. So we'll come back to this in a future workshop once we are actually working on machine learning models. Right now we're just doing this data analysis stuff. Other stuff that I got ChatGPT to cook up for me, ways to, chart the revenue for each product, and ways to create pie charts for the market share. So which, how much of our sales go to the US versus Europe, for example. Now, with all that said, if you run this code cell, it will generate a new dataset for you. So the dataset will be stored as a data frame in this customers variable. What I want you to do is to finally go through these exercises, and when you're done, you'll see a cool visualization, and you'll also see the solution down below. So that's been a neat little intro to Pandas, our data visualization library.